Hello, Zyba Scott from Pop Cannibal here to demonstrate Water Volume Advanced Buoyancy, a plugin for Unity to make things quickly float. First, I'm going to import the package for Water Volume. It's going to bring in two things: the plugin itself, which has a few files, and a copy of Unity's standard assets Water. If you don't have that imported already, it's not necessary for the plugin, but it is used by the plugin's demos and the convenience prefabs. So we're going to import that so we can have some water to play with. Because Water Volume is about the space of water, not the look of water. It's about making water float and act like it, but you can bring your own water effects. So the first way to use it is incredibly simple. We're just going to add a game object, a cube, which is going to be the space that I want to float. Put that at 0, 0, 0. And I'm going to make it nice and big so that we have a good space for something to float in. I'm going to call this my water volume. Now I'll add something to float. Let's throw in a cylinder. Now the cylinder, anything that's going to float in Unity, it just needs to have a collider, be it a box collider, a capsule collider, or mesh collider, sphere collider, and a rigid body. So we're going to add in a physics rigid body because we're just using Unity. If you want to, the mass actually does take effect in the water. So we have a cylinder, the collider, and a rigid body. We have what we're calling our water volume, and it has a box collider. And all I need to add onto there is, in the water volume plugin, I need to add the water volume script. And now it is water. Let's move it into place. So it's just below the thing we want to float. Let's also make it invisible. Just turn off the render there because we don't really want to see that white box. I'm going to hit play, and our cylinder is floating. I can duplicate the cylinder. Everything's floating. It's that easy. Water volume also includes a couple of convenience prefabs. This one called Water Volume is simply it's a box collider with the water volume script on it. So if I bring that in, it's going to make my object float. No problem. We also bring in a bit more advanced one to help you get started in seeing how to use some of the more advanced features of water volume, because as simple as it is set up, there are some really cool settings you can make. So the first one is water volume has the ability to use either just a box collider to define the area that is of the water, or inside of that box collider you can specify multiple meshes which define the surface, and those meshes can be animated, the vertices. You can animate them with a skinned mesh renderer or programmatically just moving the points in a mesh. So in this demo, we're bringing in a quad of meshes, 4 meshes, to show you how you can tile this. There's interesting things to increase efficiency that way. And each of these meshes are using a ocean tile that's included that's actually was made in Blender and is a looping tileable animation using blend meshes to animate a water surface. So let's watch our object float in there, no problem. So you can see that water volume has an option to draw gizmos. When we do that, we're going to get some extra meta information about what water volume is detected are the points of the object in water, the forces at play. Blue is the buoyancy line going up, red is various viscosity, the yellow is indicating the corners, and the green are the nearest vertices to the corners of our item. Here in the water volume inspector properties, we can see a number of things to change the buoyancy. That's an easy one, how much to make it float or not. Lower that, my object sinks in. Raise it. Viscosity, that's how thick the water will act. You can make it more syrupy, so things more drag, more viscosity goes through it. We can specify a constant directional flow that the water will push objects in. Come back. Here you can see where we've added our meshes. You can programmatically through the call methods to add and remove meshes during runtime. This can be useful, say, if you want to have an infinite surface of water where you move and you're adding and removing water tiles as you go. There's some efficiency options for how quickly you want to track the changes in the water mesh vertices positions. You can add an observer, which will, and a distance. So if you add, like, say, the camera or the observer, the water will automatically deactivate and stop worrying about objects that are a certain number of units away from the observer. This can be good if you have a large body of water and you don't actually care about things that are very far away, eating up CPU being calculated. Threading's automatic on this machine. I have 8 cores in it, so it detected those, and it's splitting up as much of the work as it can across 8 threads. You can turn that off if you're on a system that doesn't make sense to use that. Raycast spacing allows you to water volume uses raycasts to figure out how to do a surface area sensitive viscosity, but also to do viscosity occlusion. So if 2 objects are right next to each other, the one will block the other's viscosity, so it's not as if the water's not moving through the object and dragging on both of them. You can also have an only track list where you get to add objects that should you want to know how far underwater they are and how much buoyancy would be applied to them, but you don't actually want to change them. This is good for, say, adding a player character who you don't want to be affected by the water, but you want to know how to affect them manually yourself. Some other fancy options, and then some nice statistics to help you understand what's going on. This is water volume. It's both really simple to use and has a lot of options and efficiency built in. Thank you.